Hello everyone. Let us now discuss today's LeetCode POTD problem. Question number 2558. Take gifts from the richest pile. So here we are given with an integer array gifts denoting the number of gifts in various piles. That means here we are given with piles, and we are having the number of gifts in every pile. So now we need to choose the pile with the maximum number of gifts. So let us consider a pile which is having maximum number of gifts, and if there is more than one pile with the maximum number of gifts, that means if uh, there are more number of maximum number of piles, that means if the gifts is not containing only uh, one pile, that means there are many maximum number of piles. Then we choose we leave behind the floor of the square root of the number of gifts in the pile and take the rest of the gifts. That means if we are having 49 here and square root of 49 is 7, if this is the maximum, then we need to take 7 and left over the remaining in the piles. So to understand clearly, we are given with example 1, 25, 69, 9, 4, 100, and k is equal to 4. So the important observation here is the number of gifts remaining after k seconds. That means we need to do this operation of taking maximum gifts from the piles will be up to 4. That means we need to do this operation for only 4 times. So here the maximum which we can get here is 100. So square root of 100, this is at the first second, square root of 100 is 10. So when we take 10, 10 are left behind, and at the second in the second, so here we got it 10. Now we have 25, 69, 9, 4, and 10. And after taking the piles 100, then we need to consider 69. So square root of 69 will give us 8. That means 8 gifts are left behind. So here we will be having 8. So this is the second. Now 25, 8, 9, 4, 10. Here 25 is the largest. Square root of 25 is equal to 5. Now 5 gifts are left behind, and 5, 8, 9, 4, and 10. Here we have 10 gifts in this pile. So square root of 10 at the in the floor, by calculating the floor, will give us 3. Now it is 3. So we are having 5, 8, 9, 4, 3. Adding these all elements will give us 29. This is the output which we need to consider. Now let us go through the second example. Gifts given are 1, 1, 1, 1, and k is equal to 4. So whenever we are considering k is equal to 4, now we have the maximum elements are 1, 1, 1, 1, and the seconds which we are left with are 4. So we will be returning 4 as the output. And this is the second example. And the constraints which are given are gifts length will be 10 power 3, 1 to 10 power 3. Gifts of 5 will from 1 to 10 power 9, and k value will be 1 to 10 power 3. So these are the constants given. That means here, as the k value is 10 power 3 and the gifts of 5 is 10 power 9, we need to consider returning values should be long, and also the function is given in long returning type function. Now, what is the approach for this problem? So every time when you see at the first example 25, 64, 9, 4, 100, if you take this array in a manner of stack 100, and then sorry, it is 69, sorry, 64, sorry, it is 64, and then 25, and then 9, and then 4. So we need to store these elements in this way, and we need to make square root of 100 is equal to 10, and we need to push back into this stack or any other data structures, so that 10 will be automatically sorted and will come to here, and then after 10 we'll be having 64. Now take out this 64 and make it 8 and push them back into this data structure, and then 8 should be sorted to here, and then we'll be having 25, 10, 9, 8, and 4. So if you observe clearly, we need to we need to sort we need to sort and store. So the data structures will be which we'll be using is priority queue. So priority queue will be used to solve this question, as it stores in in decreasing order these elements in a decreasing order, and that can be changed and pushed back into this priority queue, and it will be sorted in this manner. So the algorithm for this question will be initializing priority queue, and then looping from through these gifts and push back this number of gifts into priority queue. Now, after pushing them back, we need to consider k operations. So while k minus minus, top element will be pq dot top, and we need to remove this element from the priority queue, and then push back the square root of the topest element, that means the maximum element, and let us consider long sum is equal to 0, and as with no iterating function for priority queue, we will be taking one element from top every time, and it will be removed from the element and added to sum. So while queue is not empty, the topest element is pq dot top, and remove that from the priority queue and add it to the sum, and after this we'll be returning our sum. So you will be getting code in few seconds. Thank you.